In this session, I'm going to be talking about fundamentals of electricity as it borders on the basic elements that you are going to be calculating when you are doing house wiring. It is very important for anyone who wants to take on the job of house wiring to know how he or she can calculate, for instance, the cable ratings, the socket ratings, the current ratings of various components. You must know how to convert from one component, that's from one element of electricity to the other. That if you are given, for instance, a value of a current, how do you get the power, and vice versa. Now, look at this formula. I'm going to give you straight the conversion. Now, there are basic component I'm going to just read out for you to just take note of. Number one, I'm going to be talking about work briefly, just the definition. Then you have work, you have power, you have energy, you have voltage, you have current, you have resistance, you have watts, and you have Ohm's law. All these elements that I've reeled out for you, they have their basis in the first description I made about atom. There's a way you can relate them to flow of electron. I'm going to be speaking more about flow of electrons to describe what I'm going to be talking about for you to understand, because it's good as a technician for you to know what happens between components. That is what happened in the households. Sometimes when you find heat coming out from a particular component, it is very, very important for you to know how this heat came about. Now, work. Work is done when electrons move through a conductor and heat is generated. It is usually said that 1 joule of work is done when 1 voltage is applied to cause 1 amperes of current to move in 1 second. I've mentioned joules without telling you what joule is. Joule is actually the unit of work. That's a unit of measurement. In engineering, you must know how certain components are measured. So work is measured using joules. The second fundamentals of electricity I'm going to be talking about is power. Power is actually the rate by which work is done, and it's measured in watts. That is, 1 watt of power is supplied when 1 joule of work is done in 1 second. Resistance of a component is defined as the opposition to the flow of electrons within its conductor. That is resistance. So you multiply the square of a current by this resistance. The resistance is usually measured, the unit of a resistance is referred to as ohms. Now I'm going to be talking about Ohm's law. Now Ohm's law states that current is directly proportional to voltage and inversely proportional to resistance. Now the formula was derived from that law. I equals to V divided by R. That is what Ohm's law states. Now, from this particular formula, you can see that when you are given current, using Ohm's law, and you have voltage, you can get the resistance of a particular component, and vice versa. You can get any of these components given at least 2 of the variables. That is how you use Ohm's law to calculate the resistance of your component. I will give you one very good example. If you go to the market to buy a cable, usually they will give you the current ratings of that cable. You can apply Ohm's law to know the resistance to the flow of current within that particular cable by applying Ohm's law. There are several components you are going to use during the course of your work. You're going to use sockets, you're going to use bulbs, and several other components as you perform your job. Usually, all these components come either with a current rating or with a power rating. When a power rating is given in watts. From that power rating, you can know the maximum of current. For instance, that particular cable will be that particular cable can absorb. If you are given power, for instance, in watt, you know that in Nigeria, our voltage, that's the voltage reference, is actually the voltage value is usually 240 volts. So that is a fixed value. So if you are given a power rating, when you know, you can calculate the voltage, for instance. You can calculate the current that passes through this particular component by using the power ratings and the voltage. You can get the current that can flow through that particular component. So that is one very good example of a case when Ohm's law become handy for you as a technician. I've talked extensively about voltage, about current, but I want to explain a little, to give you a little understanding of what voltage and current is. Voltage is usually the potential difference between two points in your circuit. There is usually a reference in determining a voltage in a circuit. Now, usually, within your circuit, the source, the power source, is one that give out the voltage. It's like a force, but that particular force is a force that is measured between 2 points. Usually, in the house that you're going to wire, you will have a reference point that is known as the earth. The ground is usually 0 volt. And you have the utility or the power source generating, pushing into your circuit 240 volts. So voltage is actually a potential difference. Don't forget that that is a difference between 2 points. It is not just a force. When you are calculating voltage, you are calculating it in reference to a particular point. You have to take note of that very well. Now, the current is usually the flow of electron, as I've said earlier, and it is measured as the rate of this flow, which is measured in amperes. Amperes is actually the unit of the flow of current. Now, in a conventional circuit, engineers have taken the movement of current to be the movement of a positively charged particles in the atom. But that is just taken conventionally because the only positively charged particle within an atom is proton. And remember, I told you earlier that it does not move. The only particle within an atom that moves is the electron. So it is usually electron that moves. So the next thing I'm going to be talking about is type of powers. We have what we refer to as a direct current power. In DC current, we usually use graph to depict, the flow of the movement of electron within the circuit using a graph. You're looking at this diagram. The diagram is usually known as a 2 coordinate diagrams. The vertical line represents the current value, while the horizontal line represents the timing. You can see that as time moves on the horizontal line, the value of current does not move at all. It's fixed. So when you see a graph like this, you know that this is a current, this is a direct current power. So it is usually depicted using a straight line. That's a direct current. Now, onto AC current. In an AC current, you have the value of the current fluctuates between a lowest value to a peak value, and it moves in what we call a sinusoidal wave, as you can see from the diagram. You can see that the value of our current moves like a sine wave. It moves from the lowest value to the peak value. In fact, it's inverted because below the horizontal line in my graph are negative value. So you can see that current within this particular circuit can change their movement. That is how AC current is depicted. In a capacitive load, the current will lead the voltage. When current leads the voltage, it means that the current value begins to peak before voltage. That is when current leads the voltage. That happens in a capacitive load. Now, the second one is when you have an inductive load. In an inductive load, you have a scenario in which current will lag the voltage. When current lags the voltage, it means that current will be delayed, the value of a current will be delayed even while the voltage is rising in an alternating current circuitry. You have these two phenomena happening only in alternating current circuitry. In direct current circuitry, you have the power factor to be 1. And I will tell you the formula of power factor. The formula of power factor is usually voltage multiplied by current multiplied by the cosine of the power factor. As you are seeing from this particular diagram, the cos, which is an engineering measurement of angle, is used to measure your power factor. You will have more details in the documentation that you are going to be given in this lecture if you want to learn extensively what power factor is.